Hi, everyone. Welcome to the Lowdown on Progressive Web Applications. Today, our front-end track feature is presented with DockYard. Our guest speakers today is Lisa Backer and Patrick Lindsay. My name is Jennifer Ponder. I am located in Atlanta, Georgia. I am the Senior Front-End Leadership Fellow for the front-end track. Our guest speakers today are Lisa Backer. She's a software engineer at DockYard, and also Patrick Lindsay, who is a software engineer at DockYard as well. Lisa Backer is a software engineer at DockYard working remotely from Arlington, Virginia. She has 20 years experience in web development, beginning with nonprofits and then moving to consulting as well as product development. Her current work is focused on front-end development utilizing Ember.js, Stencil, and TypeScript for large-scale projects. In her spare time, Lisa volunteers as the tech director for a local political party with her children's schools and coordinator for the Santa Mobile with her local volunteer fire department. For more on her, you can find her on her Twitter at ESHTADC. And also our next software engineer, so sorry about the slides, everyone. Our next speaker today, Patrick Lindsay, is a bookworm, musician, sandwich enthusiast, and software engineer based in Florence, Alabama. He is a graduate of the University of North Alabama and primarily works on React and Ember at DockYard. Now we want to get into our mission, which speaks to inspiring women to excel in technology careers. Our vision is a world where women are represented as technical executives, founders, VCs, board members, and software engineers. Also, take a look at our Women Who Code Code of Conduct. We do want to foster an inclusive and collaborative environment where everyone is welcome. If this is something that you are not seeing and there's something you want to let us know about, definitely send us an email at frontend@womenwhocode.com. And also, if you'd like to look at our full Code of Conduct, you can go to womenwhocode.com/code of conduct. Now, just some introductory information about the Women Who Code front-end track community. Definitely, if you're a member, welcome back. And also, if you're new, we'd like to welcome you today and let you just know, to let you know you can become a member, womenwhocode.com/frontend. And also, you can register for events there as well. You can email us at frontend@womenwhocode. As I mentioned earlier, here is where you can specialize. You can tell us where you want to, if you want to see any new events that are coming, if you'd like to be a speaker for us, definitely send us an email. Our social media is also WWCode Frontend, and also our Instagram is WWCode Frontend1, and we have Slack available, and you can find our Slack pinned to our Twitter. On top of our Twitter page, and also on our Instagram. You can find the link there, and also send us an email. We'll definitely send you a Slack invitation if you're interested. And now, without further ado, I'm going to turn it over to Lisa and Patrick. Thank you so much for being here today.
Thank you.
Thanks. All right, I'm going to share my screen. So, can everybody see this?
Yep, we can see it.
Great. Well, like Jennifer said, I'm Patrick, and that's Lisa, and we work at DockYard, which is a digital product consulting agency. We've got a bunch of marketing stuff here that you can read. And today we are here to talk about progressive web apps. We are going to go through what a progressive web app is, what a PWA is, the technological requirements that basically like all of the boxes that you need to tick in order to have a PWA, some advice on building them, and how to avoid some pitfalls. And we're going to talk about some performance benchmarks and some tools that will help you to build.
So the first part of that is what actually is a PWA, right? A progressive web app. You can search the web and get all sorts of different takes on it. What you're going to see in a lot of places is the marketing hype, kind of what's on this slide here, that'll say PWAs bring you business value. Google's site, for example, has a lot of case studies that say things like, George.com saw a 31% increase in mobile conversions after upgrading their site to a PWA. Their efforts also brought them faster page load times, lower bounce rates, increases in conversions, more page views, all of that. Other case studies talk about increases in conversion or twice as many page views for media businesses. But given that today is the opening of WWDC, I figured historically I would mention that a lot of the ideas were originally attributed to Steve Jobs. However, Apple kind of moved on quickly into the App Store land. And so the PWA term actually comes from a 2015 blog post by Alex Russell, who's a Google engineer. And he and Francis Berryman discussed the need to utilize emerging web standards together to get the best of the app world experience with the standard searchability and freedom of the open internet. They outlined several qualities that these new progressive web apps would have to have. They would be responsive to fit any form factor. They would be connectivity independent, so you would be able to work offline. They would have app-like interactions. Usually they were envisioning an app shell model at the time. They would be fresh, so they'd be transparently kept up to date, thanks to service workers. They'd be safe, they'd always be served via TLS. They'd be discoverable, so they would be identifiable as applications through their manifest, but also using search of the web. They'd be re-engageable, so you'd be able to access the re-engagement UIs of the operating systems, like push notifications. They'd be installable to the home screen through browser-provided prompts, allowing users to keep the apps they wanted. And they'd be linkable, meaning it'd be easy to share without having to install a giant application. In the article, he says that these apps aren't packaged and deployed through stores. They're just websites that took all the right vitamins. They keep the web's ask when you need it permission model and add in new capabilities like being top level in your task switcher on your home screen and in your notification tray. Users don't have to make a heavyweight choice up front and don't implicitly sign up for something dangerous just by clicking on a link. Sites that want to send you notifications or be on your home page, the home screen, have to earn that right over time as you use them more and more, and they progressively become apps. So that's all aspirational and nice, but from a technology's perspective, there's really three main things that you need to have to be a progressive web app. It needs to be safe, it needs to be served over HTTPS. You need to have service workers. That's basically what allows a lot of these interactions through the cache and the offline connectivity, push notifications and such. And finally, you need a web app manifest, and that's a special file that describes the metadata of your application in such a way to allow it to be rendered as an app. So Google's checklist now in 2020 details to be a PWA, they have two lists. One is the you must haves, and then one is the nice to haves. So on the must haves, number one is starts fast, stays fast. Performance is key to a PWA experience, and particularly because you're dealing with mobile networks as well. It needs to work in any browser. This means that one of the apps should be in the browser of the user's choice, but also that it should be progressive and enhanced. So you're not forced to dealing with the lowest common denominator of the apps, but you keep adding technology as it's available. It should be responsive to fit any screen size. If you want your site to behave like an app, you have to expect it to run where apps run, which is mobile devices, tablets, TVs, whatever. It needs to provide a custom offline page. So this is more of a seamless native app experience than just dropping to a browser's offline page when there's no connectivity. And it needs to be installable. This is where you get the application part. It needs to be something the user can interact with directly from their device screen. So then in the nice to have section, providing more of an offline experience. This is where you start to think about portions that should still perform when the user's offline more than just a message. It should be fully accessible. Your app needs to meet or exceed the web content accessibility guidelines, which means more people are able to use your app. It can be discovered via search. Search is one of the biggest advantages of the web. More than half of website traffic still comes from organic search. It needs to work with any input types. This is going back to supporting all the devices. It needs to work with mouse, touch, stylus, keyboard. You need to provide context for permission requests. I'm sure you've been to websites that pop up automatically asking for push notifications. They drive me crazy. That is not giving me context. You need to give the users context as to why you're asking for these permissions, and only ask when you're ready to use them. And then finally, it follows best practices for healthy code. This is probably the most nebulous requirement, but a healthy code base is generally faster and less buggy. So this is things like keeping your libraries up to date when security vulnerabilities are found, or using static analysis like linter tools, automated test suites, etc. So what is a PWA? It's just marketing. Just like HTML5 had very little to do with actual HTML, PWAs are just a bunch of technologies with a zingy new brand name that keeps the open web going a little bit longer. And beyond that, makes the web as a whole a better place for users.
So we're going to take a look at a couple of PWAs that DockYard has built. We're going to refer to these, we're going to refer back to these a few times over the course of the presentation. So we're just going to do a little demo. The first one is HighTide. This is a PWA that provides tide information for a given location. It has geolocation support, although I am not near any oceans. I'm in North Alabama, so not much relevant there. So we're going to search instead. We're going to go for Boston, and we'll just search for regular Boston. And we can see that the next low tide is 6 p.m. and the next high tide is midnight. And we can scroll forward and backward in time. And that's all well and good. We should look at the fact that we are registering a service worker here. If we toggle to offline, if we turn off our, or if we spoof our network to be offline, then the app detects that and it displays this nice banner. If we try to refresh, the app still will load, even though it can't actually fetch any data for us. Although we are caching some data, like recent places that we've looked up. So that's great. Another one is pwa.dockyard.com. This is a marketing tool that our business development team uses to educate potential clients on what a PWA is, although this tool itself is a PWA. So it's a good one to learn about some of the features of PWAs. And it also supports offline mode. And actually this app is still fully functional without an internet connection. And that's due to asset caching. So if we come in here and look at the cache storage, you'll see that we have our JS bundles and CSS bundles and icons and fonts. Everything that we need to render this page is actually stored in our browser's cache storage. So you can be offline and the app still continues to function just like normal. So back to the presentation.
Cool, thanks. So one of the first requirements that was talked about was discoverability, being able to take advantage of search. And the complaint was really that apps in the app stores are losing the benefit of one of the best things of the web, of being able to search for them in open ways. So we're talking about things like taking advantage of SEO best practices. And none of this is particularly hard. These are things that apply whether you're talking about a PWA or just a regular web project. We want to make sure we're taking advantage of basic page metadata, such as your titles and description meta tags. We need to make sure that there's indexing availability. So what I mean here are things like making sure your content's readable by a search engine crawler. A lot of the fancy JavaScript heavy apps actually give you nothing but a script tag on the page. So you need to be looking into parts of your site that are static versus dynamic, or looking into server-side rendering. And then finally, descriptive content. So this doesn't, part of this means is that your content says what it is in your metadata, but it's also that you're using appropriate image alt tags, and particularly that your texts on your links is not things like click here or this, because that's not particularly descriptive on where you're going to go. So here I thought I would take a minute to introduce Lighthouse because it's a tool that you'll become very familiar with when you're working with PWAs. Lighthouse is actually an open source automated tool from Google that is built into Chrome. You can use it directly from the dev tools. And it's for building improving the quality of web pages. It's got different audits for performance, accessibility, progressive web app scores, SEO, other best practices, and each report gives you a score, and then a list of your past audits and failed audits. So these audits can give you more information about what you need to fix to make it better. It's a very handy tool, and for any, like I said, any work, not just PWAs, although it does have PWA specific features. And we'll come back and take a look at this more in depth at the end, but I wanted to bring this up as a good tool for SEO. And then, how do your users discover your PWA? How do they know to install it? You can publish it in PWA specific stores. There is progressiveapp.store, although not all your users may know to go look there. There's actually including it in the more well-known app stores. So as you may know, there's different processes for how to submit software to go into Apple Store or the Google Play Store or the Windows Store. There's also some tools though that can make it such that they can spit out those packages for you to submit just based on your PWA alone. And PWA Builder is one of those. That's where I took this screenshot from. Then finally, like we said, discoverability of search. You can just have people discover it using organic search and using site promotion. So you can install directly from your site.
So let's talk about actually installing PWAs. So there's a myriad of reasons that you would want users to do that, but the primary one is that the users who choose to do that are your most engaged users, and by installing you can keep them engaged. Like Lisa said earlier, installing apps gives us all kinds of capabilities like push notifications and whatnot to keep users coming back, and also just having the app present on their home screen is going to keep it more top of mind than a website that they have to remember to go to. So how do we install apps? Well, it all starts with the web app manifest. So the web app manifest is a static JSON file, much like a package.json, that just helps the user's device understand how to translate your web app into a more native experience. So it includes things like name and description. The start URL is comparable to like the entry point of a React app. And then it includes some visible options, background color, theme color, some icon declarations. So I want to call out a few of those visual options. The first one is background or theme color. That's two distinct options. So this is HighTide installed on a Mac. And you can see that up here at the top, we've got a nice blue that's in line with our app's color scheme. And that's because we set the theme color entry in the manifest. Next is display mode. So there are 4 options for display mode. You can go with browser, minimal UI, standalone, or full screen. Each of these has its own implications, but they all have to do with the amount of browser UI that is displayed, or OS level UI that's displayed. So this is a screenshot of HighTide installed on an iPhone, and HighTide uses the standalone display mode. So we get the status bar up here, but we don't get a navigation bar, a search box. We don't get forward and back buttons down here. If we had gone with the browser option for this, then we would get both of those things. Icons are another important one. So icons is going to be an array, and you're going to want to have have an entry for each of the different resolutions. So 2x, 4x, all of the normal ones that we're used to with modern web apps. And then the splash screen. So this is a screenshot of HighTide launching from an Android phone, Android is going to automatically generate the splash screen based on the background color that you've specified and the relevant icon and the name of the application. iOS requires that you include some special meta tags in your markup to more manually define what the splash screen should look like. So how do users install it? Well, the browser gets to decide whether or not your app is installable, and you have to tick several boxes in order for the browser to give you the go-ahead. So the first one is that you need to meet the PWA requirements. So these are the 3 strict requirements we talked about earlier. You have to have a web app manifest, you have to serve the app over HTTPS, and you have to register a service worker. If you are doing all of those things, then you have a PWA, and that's your first hurdle passed. Second one is that the app needs to not already be installed. The browser is not going to prompt the user to install the app if they've already done so. And then the third one is the least obvious and the most kind of nebulous. So each browser has their own proprietary algorithm that decides whether a user is sufficiently engaged with your application that the browser thinks that they might want to install it. So that's not really something that you can predict, but it's something that you just have to plan around. But once the browser has decided, yes, this user likes this app enough, they've used it enough, they've engaged with it enough, they're a good candidate for wanting to install it, then it will tick this box, and at that point, it becomes technically possible to install the application. So next, we're going to look at a code sample for how we might actually present an installation prompt to a user. Let me get my pointer here. Okay, so this is a React flavored example, and it's pretty contrived, but it gets the point across. So the kind of magic that powers all of this is this before install prompt event. And this is kind of the technical manifestation of the browser deciding that you tick all those boxes that I was just talking about. Once the browser says, okay, all three of these things are go, then it's going to fire this before install prompt event. So here we've got a header and we've got a button, and we're only going to display the button if the app is installable. We've initialized it to false. And so once the browser finally decides to fire this event, we're going to do a couple of things. We're first going to stop the event from bubbling. We're going to store the event object out. And then we are going to toggle our button to true. And at this point, the ball is in the user's court. So once we set this flag to true, our button becomes visible. And we've defined it to have this click handler right here, which is this install function here. So when the user clicks on the button, we're going to drop into our install function. And at this point, all we're going to do is we're going to pull out that prompt event that we saved out. So that's just the result of this line right here. We're just going to pull that out. Oh. Sorry, my scroll wheel has been getting the better of me. So we're going to pull the prompt event back out, and we're going to fire the prompt method. And this is what's going to actually present the browser prompt, the browser level prompt to the user. So in a Chrome flavored browser, that would be the thing that comes down right here and says, hey, do you want to install this? Yes or no. This method returns a promise, and that promise resolves whenever the user makes a decision there. So when the promise resolves, we're going to check the outcome property of it. And if the user accepted, then we're just going to log out accepted. And at that point, the app is going to start installing. Once the app finishes installing, the browser will fire this app installed event. And at that point, we're going to log out app installed and toggle the button back to invisible because the app's installed. They can't install it again. We're good. So like I said, this is a relatively contrived example, but it gets the point across. So some things to keep in mind with installability, user experience. You want to stay outside of the flow of user journeys. You know, if a user is in the middle of checking out, or if you are working on the Gmail application and the user's in the middle of writing an email, you don't want to be interrupting them to say, hey, do you want to install? You want to let them finish what they're doing. You want to do this at contextually appropriate times. You also want to make sure that you're not taking over the screen, that you're not preventing the users from doing anything. If we look back at this illustration, this prompt doesn't block any of the app's UI. It's up and it's out of the way. And also, you want to give the user the option to say no. We don't want to be pushy about this. We don't want to be jerks about it.
All right. So once you've got things installed, or you at least have your framework set up, one of the most important things on that PW checklist was speed. Performance on the web can be hard because there's so many features that have been added in so many different connectivity situations and so many different devices. But performance is more than just having like a good score at the end from Lighthouse. Performance is actually about a lot of things. It's about retaining your users. Studies show over and over that increased performance leads to lower bounce rates and longer sessions. It's about improving your conversions. So slow sites have a negative impact on revenue. If you're working on something that uses ad revenue, for example, DoubleClick found that sites that loaded within 5 seconds got twice as much revenue. Performance is about user experience. So until your initial paint happens on your first render, there's actually no user experience at all. So if you require shipping a lot of code down just to do that first render, you're leaving people wondering and possibly they're abandoning you. And finally, performance is about people. Not everyone has super fast internet. There's always the discussion about the global audiences, but there's problems here at home with rural populations or lower income users who may have a slower mobile connection and a slower mobile device. So there's a lot of ways to quantify this. So we're going to look at just 2 of them today. The first is the rail model. So this is a user-centric performance model that breaks down user experience into a couple key actions and defines goals and guidelines for each one of those. It breaks it down into the 4 aspects of the web app life cycle: response, animation, idle, and load. Because UX research shows that users have different expectations for each of these types. So in terms of response, this is responding to user interactions, not responding to a whole page load. So things like clicking a button or toggling a form control. The user needs to be able to tie their action to the response on the web page. So they lose that after about 100 milliseconds. And the goal here is actually set to 50 milliseconds, and we'll see why in just a second. For animation, obviously this is visual smoothness, so it's usually focused on rendering performance. The eye sees things as smooth at 60 frames per second. If you divide that out, it's actually 16 milliseconds, but this model gives about 6 milliseconds to the browser to render that. So the rest is for doing your work. Idle, this is when the user is not actually interacting with the page at all. They're just reading or something else. And that's when you can do background work. So if you just loaded the bare minimum to get that paint up, then this is where you can do some more. You can start caching things in the background. And they advise to keep your chunks here at 50 milliseconds so that if the user does interact, you have that other 50 to go back into the response portion and make sure that your response is fast enough. And then finally with loading, this is where we traditionally spend most of our time optimizing. This is the initial page load. So when it's slow, users think it's broken, right? And this 5-second goal that they set actually seems kind of long compared to how aggressive the other goals are. But this is for over mid-range mobile devices with slow connections. Subsequent loads should be faster still. And then, so I also want to talk more about just measuring this, because it's all well and good to say 100 milliseconds, but it is hard to test some of those things. You can take strict measurement of your own site. You can use Lighthouse. Again, is this where this one's coming through? On Lighthouse, there's 6 key metrics that are captured. The first contentful paint and the first meaningful paint, they both have to do with how long it takes the browser to render the initial and primary content. The speed index is how quickly content is visually displayed during the load, and you can actually see at the bottom there, it'll show you little screenshots of what it saw. It actually uses a tool called Speedline to generate that score. And then there's first CPU idle and time to interactive and max potential first input delay. They basically all deal with how long it is for the interactivity of your page to work. So when users can actually do something other than just see it. There's also a really elaborate trace that you can see from this report that will allow you to dig way in. I didn't put it in here though, it's a lot to look at. So a lot of the things that I've been talking about, I mean, Patrick's been going more into details, but a lot of things I've been talking about are things that are, again, not specific to progressive web apps. But I really liked this concept here that the progressive web apps as a Trojan horse for website performance. For all the showy features of progressive web apps, push notifications, offline usage, icons on the home screen, app stores, etc., the part of a progressive web app that will likely have the biggest impact for your users and your bottom line is performance. If the pursuit of those showy features causes your organization to build a faster experience, then everyone wins. And then how do you get there, Patrick?
All right, so we've been talking about a lot of cool things, and service workers power most of the cool things that we can do with PWAs. So what is a service worker? It's really just more JavaScript. But it's JavaScript that runs in the background. It doesn't have access to the DOM, and it doesn't need the DOM. And it runs separately from your main application. And it's responsible for a lot of things. One of the most common things is being a network proxy, which means being kind of a man in the middle between your application's desire to fetch data and the network layer. So the service worker is often, it often enables these like performance improvements, these speed bumps, by caching information and then preventing unnecessary network requests by pulling that cached information back out. And one important thing to note is that service workers are terminated when they're not in use. And what that means practically is that any state that your service worker is going to rely on needs to be divested from the script itself. It needs to be stored in local storage or in one of the browser's multiple caching APIs, but it needs to be stored somewhere like that where it can be persisted across multiple runs, and you'll have to pull it back out later. So one of the biggest things that service workers give us is push notifications. So before we get into how to implement push notifications, I want to talk a little bit about best practices around them. So Lisa mentioned earlier websites that ask for push notifications as soon as you land on them. In my opinion, news websites are some of the worst offenders about these. No, thank you. I will decide when I want to check the news. You want to make sure that you are asking for this permission when it makes sense to the user, not just doing it as soon as they land on your page. And you want to make sure that you are explaining to the user why they should care. You want them to be bought into the idea that you're going to get to interrupt their lives with your software. And lastly, you want to make sure that you are asking permission after you are pretty confident that the user is going to say yes. You want them to have indicated some explicit interest in having push notifications. And the reason for that is that you only get to ask once. In order to prevent applications from spamming users, browsers store the user's decision on whether or not an application can send push notifications. And if the user says no in that browser level prompt, the browser is going to remember that, and it's not going to let the application ask for permission again. So you want to be pretty sure that they're going to say yes before you use your one shot. So now that we've talked about that, let's talk a little bit about how to implement this, and we're going to look at a little more code. So this is some framework agnostic code walking through how to request permission. So the first thing that we're going to do is we are going to check and make sure that the user's browser does support push notifications, because not all browsers do. So the way we're going to do that is just check the window object, the global window object, and see if it has a key called notification. If it doesn't, we are just going to log a message and return. But assuming we make it past this guard clause, then we know that we will have access to the global notification object. So the first thing we're going to do there is check its permission flag and see if the user has already granted permission previously. If they have, then the permission flag will have a value, a string value of granted. This is a constant, you can count on it. If they have not granted permission, then we're going to request permission. And the way we do that is we call notification.requestPermission. This is a browser API that returns a promise, and the promise resolves when the user makes a decision. Once that resolves, we're going to see if they said yes. And if they said yes, then we are going to dispatch a notification. And we do that by just instantiating this notification class and passing it the message that we want in our notification. So this is how you would dispatch a notification from your main application. But you can also dispatch push notifications from the service worker. And you would do that using something like this. We've got a guard clause here at the top, making sure that we do actually have permission to send push notifications. And if we make it past that, we're just going to pull our service worker's registration, and then we're going to call the show notification method on that, again, passing it the message that we want to show to the user. So next I want to talk about offline experiences. Offline experiences are another way that PWAs distinguish themselves from other web applications, and they would not be possible without the service worker. So when we talk about offline experiences, we can mean like fully rich interactive experiences, as long as those interactions don't require network traffic. But you don't have to have something so in-depth in order to qualify as a PWA. It could be something as simple as just, oops, you're offline HTML page. I like to use Instagram as an example. You know, if you pulled up Instagram while you're in airplane mode, Instagram's not going to be able to show you your friends' stories and their photos and everything. But it's not just going to show you a blank white screen. It's going to be branded. It's going to be familiar to you as Instagram, but it's going to say like, hey, sorry, you're offline. There's not a lot I can do here. So we're going to look at something like that, just a basic, just a basic branded offline page. So this is a service worker file that we have here. And we're going to imagine that we already have an offline.html that has our branded notification. And so we're going to walk through how an implementation of this would work. So the first thing that we're going to do is we are going to register an event listener for the install event. So when the service worker is first loaded into a browser, it's going to be installed. It's going to be registered and installed in the browser. And once that's done, the browser will fire this install event. So at that point, we're going to tell the service worker, hey, first thing you need to do, don't continue executing. First thing you need to do is load the cache. So we're going to we're going to tell it to wait until this promise returns. The wait until method just accepts a promise and it stops until that promise returns. And we're going to pass it this init cache function. And init cache is going to do two things. It is going to open a cache. So this is actually your browser's cache storage section. We've named our cache up here, defined a constant. And the caches is a global in this context. And the open method accepts a name, and it's going to open up a cache. It's going to return a cache if one exists. And if one doesn't exist, it will create it. Then we're going to make a new request for our offline HTML and store that in this variable. and then we're just going to call cache.add, and that's just going to plug our HTML into that cache. The next thing that we're going to do is, sorry about that scroll wheel. The next thing that we're going to do is register another event handler, for this time for the fetch event. So this goes back to the network proxy man in the middle that we've already talked about a little bit. And all we're really doing here is wrapping all of the application's requests in a try-catch block. So we're going to take the fetch event that comes through, we're going to call respond with, and we're going to pass in our fallback function, which again is just kind of shimming it with a try-catch. So if we look at our fallback function, what it tries to do is it takes the user's or the application's initial fetch request, and it tries to fulfill that as requested. But if fetch throws an exception here, then we're going to open up our, we're going to log out an error, and then we're going to open up our cache and pull our offline HTML out of the cache and serve that. Now, it's important to note that fetch is not going to throw an exception for a 404 or for a 500 or a 503 or something. Fetch only throws exceptions if it's unable to make the request. 404s are valid response codes. Or valid responses, at least. It's not what the user wants to get. It's not what we want. But it is a valid response, and it's not going to cause fetch to throw an exception. If fetch is throwing an exception, that means that either there's no network or something else strange is going on, and we can be pretty confident that showing an offline page is the appropriate course of action here.
So that's using that same basic structure of the life cycle of a service worker. You can actually do some pretty elaborate cache strategies. There's a lot of recipes out there on different service worker sites that will go through very specific things like loading Google fonts. But in general, there's some really basic strategies you can think about for your content. The first one is called network or cache. And in this situation, the worker tries to load the most up-to-date content from the network. But if it takes too long, then it just goes ahead and grabs it from the cache instead. This is when you really want to show the most up-to-date, but it's more important to be fast. Next up is cache only. In this case, you only load from the cache. So this is when you have some static assets like your logos that never change, or maybe some audio assets or something. It's also good if you're using something just to render the shell around your application. Then there's a cache and update. So this is the strategy where a worker delivers content from the cache, but then after that's delivered, it goes to the network and gets a fresh copy to prepare for the next call. So this is content that maybe isn't quite as time sensitive, but you still expect to change. There's cache update and refresh, which is just like the one above it, but as soon as you get that new content, it actually calls the UI to update immediately. And then embedded fallback is kind of like our offline page that Patrick was just walking you through. This is where you have content in the cache already to show when a resource can't be loaded. Also use it for, images and such. You don't really need to use one kind of caching strategy for everything. It's not a one size fits all. You can mix and match things to get the right balance of timeliness and performant responses for your app.
So just to elaborate on caching a little bit more, we talked about a bunch of ways that we can automatically cache things and make these decisions for users. But that's not the only way to do it. We can come up with experiences where users have some agency in tailoring their own offline experience. So a simple example for this would be manually caching specific assets that the user has requested. So this is another fairly contrived example, but we can imagine having a news site or a blog where we might want to give the user a button to save an article to read later when they're offline. And this is one way that we might implement that. When the user clicks on the button, we just open up the relevant cache and add the add the appropriate HTML to it, add the appropriate assets to it. Now, this implementation right here would require having a service worker that is aware of the article caches and so on and so forth. This is not a self-contained example, but it illustrates how we might facilitate the user side of that experience. I want to call out Create React App. So if you're using Create React App, you have a service worker, whether you know it or not. In Create React App 1, the service worker was on by default, and it does a lot of asset caching for you. You get a lot of offline stuff for free. If you're using Create React App 2, then you have to manually invoke your service worker to register it. But the service worker is already there, and it's ready to do asset caching for you. You just have to opt in. And actually, behind the scenes, Create React App is using a Webpack plugin called Workbox Webpack plugin, which gives you offline asset caching for very little configuration. It's a really easy way to get up and running. So if you're not using Create React App, but you are using Webpack, that's a good place to start.
So simple caching can do wonders for your site performance, but when we talk about offline experiences, sometimes you're talking about something even more. If you want to store large files offline, like videos or such, or if you want to have portions of your application that are really an application offline where you're taking user data in and processing it, maybe to sync back up to the network later. One of the things that's available to you is IndexedDB. This is a transaction database available in the browser, particularly for storing larger files, more than what your small cache would do. It's the same origin policy, so as pretty much everything else, so you can only do same domain. And it's available to web workers, so your service worker has access to it. It's not a traditional database of table rows and columns, it's an object store, so it's a NoSQL system. You can use this in conjunction with background sync, or you can use background sync on its own as well, but what background sync is it allows us to handle that occasional connectivity piece. So basically, you can offload work until the user has a solid internet connection again. You register and listen for when the user's online, and then instead of just calling your code to do a network process directly, you wait for the event to say that the user's online. And if they are, it'll fire right away, and then your code, you can do your processing right away. But if they're not, it'll wait until they are online again and then automatically fire off that code that you wanted. Your code has to return a promise, and then if it fails, then it's considered a failed synchronization and it will try again automatically. So you get all that built in. Unfortunately, this is not fully supported yet, and there are some good solutions out there in the meantime that combine these two concepts, especially to make more of a offline experience available, like PouchDB. Workbox also that Patrick just mentioned includes a background sync package that works with the other Workbox modules, and it already has a fallback built in for when background sync is unavailable. Oh, and then finally, we would be remiss if we didn't mention some of the user experience concepts that are required for progressive web apps. And again, these are features that are not really specific to PWAs, but required for PWAs as a better experience. So responsive design, any website or application will be used on a mobile device, whether you've designed it for that or not. So you need to plan on it to make sure things are appropriately sized for form factors. That's going to mean that you have to code for multiple inputs and different types of keyboard touch and mouse events that are going to be fired. If you're using the correct semantic elements like buttons and anchors and form controls, then you're going to get a lot of this stuff out of the box. Plus, it's also good for accessibility. There's some experiences you can provide for specific inputs like pull to refresh on their phone. Don't forget that a screen size is not how you dictate input support. So large screens can still have touch. Small screens might still need a keyboard and a mouse. So you have to have everything available. Finally, accessibility. So there are numerous discussions on the web, in person, in government, in the court cases about the need to make accessible products. And somehow we need continual reminders that the web is a diverse place and should be welcoming to all. Sites that don't conform to web accessibility best practices are shutting people out. Accessibility isn't just about limited vision, it's also hearing, cognitive disabilities, as well as mobility. Disabilities can be permanent, temporary, or even situational. So many of these best practices for making accessible web content, they also assist with things like search engine optimization and speed. So it really is a win-win for everyone to focus on these. I just have to say that Patrick and I are extremely lucky at DockYard. We have a specific discipline of UX developers who are experts in translating design into usable web content. And this means they're CSS wizards, which is awesome, but they're also wizards in semantic markup and accessibility best practices. So if you don't have access to work with someone like that at your company, there are still tests that you can utilize to make sure that you're conforming to some best practices. So here we are again with our friend Lighthouse. Lighthouse has a whole section on accessibility, and it provides a review of some automatic audits, like the use of appropriate ARIA tags and navigational items, color contrast, and some common markup problems. But there's other scanning tools out there like Axe and Wave that will do some manual testing or some automated testing for you as well. No matter what, though, you're going to have to get into some manual testing. And Lighthouse in its report does give you a section of additional things to check manually to kind of give you some guidance on how to do an accessibility review of your own.
All right, so we've talked about a lot of the cool things that you can do with PWAs, but I want to step back a second and talk about some of the ways that you can get yourself into trouble with them. So the first thing is server-side rendering. So this is another React flavored example where we are defining a button component to allow the user to opt in to push notifications. And this is just reusing the example that we looked at earlier as far as requesting push notifications. So this seems great. And we can imagine invoking it like so in our application. However, if we're using server-side rendering, or at least some implementations of server-side rendering, we might have this problem. Window is not defined. The server doesn't have a window object. But luckily, there's an easy way around this. React and Next.js and Gatsby all ship their own versions of this. But what we want to do is lazy load the component. So what that means is that we don't want the server to try to render this component into markup. We want the application to wait until it's firmly in the client, firmly in the browser before it tries to run this code. So the way we do that is we pull in this lazy function from React, and again, Next and Gatsby have their own implementations. And instead of importing the normal way, we're going to import inside an anonymous callback that we pass to this lazy function. And that will, again, lazily import our component, and everything will just work. The next thing is feature support. And this is kind of a big thing. We get to use lots of cool APIs with PWAs, but browser support is not really as great as we would like it to be. And the biggest offender here is Safari, specifically on iOS. So iOS Safari does not support Bluetooth or near field communication. It has partial support for the WebAuth API, which would normally enable things like using biometrics, fingerprint sensors, or face sensors to authenticate. iOS only supports the use of USB security keys, which would be like plugged into your iPhone's Lightning port. It does not support push notifications. It does not support speech recognition. It doesn't support the native contact picker API. As I mentioned earlier, you have to do special things in your markup in order to get the splash screen to render properly. It's got a lot of support problems. Luckily, there are some tools that can help you figure this out. What PWA can do today and what Web can do today are both really cool tools. These will show you what the device that you're viewing them on can support. So they're not super useful for figuring out, like what what all your users can have necessarily. But if you have the device that if you have access to a device that you're curious about, these are good ways to play around with things. Can I Use has like a full support matrix and is pretty popular. So if you're not familiar with Can I Use, you need to be, no matter whether you're doing PWAs or just regular web development. And the last one is, in my opinion, the least obvious of the three pitfalls. And that is a special consideration that we need to make when using service workers with the browser cache. So I think most of us know that that most modern browsers have a built-in cache that try to save the user some time when loading pages by reusing JavaScript and CSS and HTML assets from previous page loads. However, this can be a problem when you're using a service worker. So if you have a service worker that's responsible for serving, for proxying those network requests and really for serving your application, and let's imagine that we were to deploy a bug in our service worker. Well, if the service worker is broken and needs to be patched, and the service worker is responsible for serving our whole application, and the browser has cached the service worker, it's possible to get into a situation where you can't update anything about your app until the cached version expires, which is potentially up to 24 hours. Luckily, there's an easy way around this. We just need to set a cache control response header with a really strict directive: max age 0, no cache. This will tell browsers, hey, leave that service worker alone. Please fetch it every time I ask for it. Don't ever try to cache it. Now, that does not mean that you have to add this response header to all of your files if you're using a service worker. It's only for the service worker itself. But it's just something to be aware of.
I kept promising things about Lighthouse, and in the interest of time, I'm just going to gloss through this really quickly. But I wanted to make sure everyone understands. I said Lighthouse you could get to from Google Chrome DevTools, and that's just one way you can run it. You can also install it as an extension. You can, and a fun thing is that you can run it on any URL, not just your own. So if you can pull up, whatever website you like and see how they're doing. You can run it on the command line, passing in a URL. You can run it through a node module and have it generate reports out for you. You can even use something called Lighthouse CI, which will helps you integrate with something like Travis and GitHub, and you can set up the audits that need to pass before you allow pull requests to be merged. So you can get really detailed with this and very strict about enforcing your standards across your team. There's even a CI server if you really want to get fancy and look at visualizations over the last several days. And then we have, I think we should probably skip through this,
Okay.
but it's suffice to say you can pretty quickly go through and run your own Lighthouse report. So yeah, hopefully this gets you a bit more empowered to explore the technologies of PWAs. It's just a collection of awesome open web technologies that these techniques can work sometimes just for your regular web projects, but it can also enable a full-on PWA. Makes the web a better place for everyone. And so I'm at EshtaDC and at that darn Pat for Patrick. And it sounds like we do something with questions next.
Yes, so we're going to open the floor up to questions. I'm going to look at our Q&A in our chat here, and I'll just open it up with the lead-in question, Lisa and Patrick. If you can just give us some of your favorite PWAs that you've seen so far. I want to say I remember looking at either it was New York Times or Huffington Post, either one of those. I was looking at a list probably about a month or two out, and just trying to think of some other progressive web apps, real world applications that people can look at, if they want to take a look on their own.
Yeah, Twitter is a really high profile one. And I think they've got a pretty decent implementation of it. Lisa, do you have any others off the top of your head?
Flipboard is one that gets referenced a lot. I believe Pinterest has been going to a PWA model as well. And Spotify has done some PWA work. That's
oh yeah, Spotify's done some interesting
stuff.
Okay, yeah, Pinterest, I heard of them as well. doing that?
I've been noticing lots of places that I didn't really expect to have PWAs, where nothing is springing to mind right now, but I've definitely noticed a lot of websites lately are starting to have the little plus sign that shows up in the right side of my Chrome URL bar. So I think it's the kind of thing where lots of people are kind of progressively enhancing their applications and slowly opting into some of these technologies.
But and that's part of it too, is people tend to do a slow strategy with it. When they're these larger sites, they'll bring in the service worker, they'll bring in some other pieces. Maybe if they have an older, bigger site, it'll take them a while to get everything on the HTTPS. But like as they slowly add these, and then you put your manifest in there, and you're ready to go. So it's not something that people have to opt into all at once.
Yeah.
Awesome, awesome, and love these resources here. Now, are there any, because I know sometimes we do like to just share some resources too for people if they have not heard of PWAs, and I know these are great here. Any other ones that you can think of that are just, you know, really, I would say for someone that's starting out who probably is not familiar with, you know, web development, you know, on a senior level, but, you know, if they're getting started, I know these are great to read all about it, but if they have, you know, somewhere that they could play with a PWA and something like a code sandbox or something on their own, kind of like, I'm trying to think of the other, it's another platform that you can go and just play with, web applications on your own. Is there any other place that you could think of, probably for someone just getting started out and want to create one on their own, kind of like in a web scene, kind of like Code Sandbox?
I think Code Sandbox does have some specific support for PWAs, although one of the things that's kind of helpful is the, I think we have it on here, PWA Builder, the very last thing that's down there. It does a couple cool things. One is like you can put in a URL to your existing site and it'll tell you what's missing and kind of generate the manifest for you and let you see it and give you like some different strategies for service workers. But it also, if you go to their GitHub repo, which they link to from there, they have starter packages that you can just install and start running right away. And it starts with like 100% Lighthouse score, and you can, you know, just start adding your features in from there. So that's a good one to see just how everything gets set up initially. I know that's always the hardest thing for me, is starting.
Right, I understand. Yeah, that's awesome. So if anybody wants to try out the PWA Builder, definitely take a screenshot of these resources. I just wanted to open the floor up. We're going to move into some closing updates. Thank you so much, Lisa and Patrick, for your talk today. Definitely very engaging and gave us some great insight on PWAs. I know I'm familiar with them and want to get more into building my own as side projects as well. This was a very, very good talk, and I love those resources that you shared with us. And also, too, everyone take a screenshot. Just if you want to get in touch with Lisa or Patrick here, and also all these great resources, definitely going to give you just a moment to take a screenshot here of those. And also, too, we will be, this talk is going to be recorded, so we will be sharing out the recording as well. So what I'm going to do now is just share our closing updates for today.
Do you want me to let go of my screen share?
Yes.
Okay.
All right, this should be coming up in just a second. All right, everyone. So just to let you know about our closing updates that we have coming soon, our Slack study group, our Front End Friday at 2 p.m. will be back this week. We were off over the previous 3 weeks just because of our Women Who Code Connect Digital, and we didn't want those two events competing at the same time, but we're going to be back same time, same place moving forward over the next few Fridays. Also, we're coming back with our Ask Me Anything sessions for front end development. So if you're definitely interested in that, any portfolio reviews and resume reviews, definitely keep on the lookout because we're going to be scheduling those soon. Also, we want to welcome our new leadership fellows to the team who will be leading front end and mobile. Mary Kate Comer and Kamari Patrick. You will see them over the next few weeks, taking on leadership for these tracks and also leading on their first event on June 26th. So you can take a look at womenwhocode.com/front-end, and also to become a volunteer. Also go onto our website, womenwhocode.com/front-end/get involved if you'd like to join our leadership team as a lead or an evangelist for the front end or the mobile tracks as well. And also want to give a awesome thank you and a big shout out to our track sponsor, BCG Digital Ventures and the Home Depot. And also thank you all for watching our presentation today. And thank you so much, Lisa and Patrick, for being here today and for your talk. Just incredible. We encourage you all to get into the discussion at front end, at our front end track Slack. You can also join us via email, frontend@womenwhocode.com, and let us know what you'd like to see coming next. So thank you all today for your incredible talk, and also thank you to our audience. And Zaina from our audience just said thank you, and we will see you all in the future online.
Thank you.
Thanks.
Thank you all. Have a good day, a good morning, or a good evening, wherever you are.